Hello friends, I am Shreyans Bhatia from Bhatia's Training and Consultancy. First of all, Happy Dussehra to everyone. We are looking at mole concept and stoichiometry, and today we are gonna start and finish off with the basic concepts of stoichiometry. We have already seen a couple of things, that is Gay-Lussac's law and mole concept with Avogadro's law. If you haven't seen, please in the above card. Let's start with stoichiometry, the branch of chemistry that deals with the application of the laws of definite proportion and the conservation of mass and energy to chemical activity is called stoichiometry. To understand it in more basic words, we can say it is the calculation of quantitative, that is the things that can be measured, quantitative relationships of the reactants and the products in a balanced reaction. It can be used to calculate quantities such as the amount of the product that can be produced with the given reactant and percentage yields. Basically, the measurement and a relationship between the reactants and the products. Now let's see stoichiometry in a simple term. If we need 2 slices of bread and 1 slice of cheese to form one sandwich, then how many slices of bread will be required to make 7 sandwiches? So obviously we will need 14. And the balanced equation is our conservation factor here. And that is what stoichiometry states. We have already applied this in the mole concept, in the Avogadro's law, and the Gay-Lussac's law. So now let's see concept of percentage composition. It is the percentage by weight of each element in the compound. And that's a very simple logic. How much weight does an element in a compound by percentage has? That is what percentage composition talks about. Percentage composition can be given by weight of the element in one molecule of the compound divided by gram molecular weight of the compound into 100. Therefore, percent composition is also the percent mass of atoms of an element present in 1 mole of the compound. Let's see a couple of examples based on percentage composition. Calculate the percentage by weight of the following. Potassium in potassium dichromate. So we have potassium dichromate as K2Cr2O7. When we find the total molecular weight of K2Cr2O7, we find 2 into 39 plus 2 into 52 plus 7 into 16. Here we get this to be 294. And we know that the weight of potassium in potassium dichromate is K2, that is twice 39. This gets to 78. Now the percentage composition of potassium would be, percentage weight of potassium would be 78 divided by 294 into 100 as its percent. So we get 26.53%. That's your final answer here. And phosphorus in calcium phosphate, that is Ca3PO4 twice. So calcium phosphate's entire molecular weight will be 3 into 40 plus 31 into 2 plus 8 into 16, which comes out 310. And we know that phosphorus is 2 in this, so 31 into 2 is 62. So the percentage composition of phosphorus will be 62 divided by 310 into 100, which gets to 20%, and that will be your final answer for the second bit. Now let's look at the next numerical. Calculate the percentage of water of crystallization in washing soda, that is Na2CO3.10H2O. Here dot 10H2O is the water of crystallization, and that you should know by default. The total molecular weight of washing soda is 23 into 2 plus 12 plus 3 into 16 plus 10 into 18, that is the weight of water. Here we get 106 plus 180, that is 286 is the total molecular weight. Now weight of 10 molecules of H2O is 180, so percentage composition of 10 molecules of H2O will be 180 divided by 286 into 100, and we get the final answer as 62.93%. And that's your final answer for this question. Now let's look at the next question. Calculate the number of molecules of water of crystallization in copper sulphate crystal if 10 grams of hydrous copper sulphate crystals give 6.4 grams of anhydrous copper sulphate on heating. That is 3.6 grams of H2O is present in 10 grams of hydrous copper sulphate crystals. And how did we derive this? So that's simple. 10 grams was given, from which after heating we only got 6.4. So the simple subtraction will give you the answer. Now let's assume CuSO4 dot XH2O. It has weight CuSO4, that is 64 plus 32 plus 4 times 16, which will come out to be 160, and one element that we forgot is X times 18 plus X times 18, that is what? Weight of water. We know that percentage composition equals to the weight of water, that is X times 18 divided by total weight into 100 will be equals to 3.6 divided by 10 into 100, because we are given that 3.6 grams of H2O is present in the hydrous solution. And when you simplify this, we get X equals to 5. Therefore there are 5 molecules of H2O in hydrous copper sulphate crystal, and that's the final solution. Now let's look at the next concept, that is empirical formula. So empirical formula is the formula of a compound which shows the simplest whole number ratio between the atoms of the elements in the compound. Let's see, for example, glucose. Glucose's molecular formula C6H12O6, that we already know. The whole number ratio, that is 6, can be taken out common from it, so we get 1:2:1 as the whole number ratio, and the formula that is derived from it is called empirical formula, that is CH2O is the empirical formula. Similarly for benzene, we have C6H6, so 1:1 is the ratio, and hence CH is the empirical formula for benzene. So how can we determine empirical formula of a compound? So let's take an example that says determine the empirical formula of the compound of sodium, sulphur and oxygen having the percentage composition, that is sodium is 29.11%, sulphur is 40.51% and oxygen is 30.38%, where the atomic weights are given. So now let's create this table. So element is sodium, percentage composition is 29.11, atomic weight is 23. So relative number of atoms will be 29.11 divided by 23, which comes out to be 1.266. Now again do the similar stuff for sulphur and oxygen. So we get 1.266 and 1.898. And now which is the smallest number? That is relative number of atoms which are least are of sodium or sulphur. So divide by the least number, to get a whole number, because empirical formula are the whole number ratios. So 1.266 divided by 1.266 will be 1. This will be again 1, and 1.898 divided by 1.266 is 1.5. Now it should be a whole number. So is 1.5 a whole number? No. So we will multiply by 2 to make it a whole number, and it's a ratio. So if we multiply oxygen by 2, then we'll have to multiply sulfur by 2 and sodium by 2 as well. So we will get the final simplest whole number ratio as 2:2:3, and hence the empirical formula is Na2S2O3. And what is molecular formula? It is the chemical formula which represents the actual number of atoms of each element present in a molecule of the compound. That is, what is the actual composition of the molecule. So for example, in glucose, the molecular formula is C6H12O6. That means there are 6 atoms of carbon, 12 atoms of hydrogen and 6 atoms of oxygen in this compound. Similarly, in sulfuric acid, H2SO4, 2 atoms of hydrogen are there, 1 atom of sulfur is there, and 4 atoms of oxygen is contained. Now let's see a couple of examples. Determine the molecular formula of a compound having the percentage composition of carbon, hydrogen and oxygen as 26.59, hydrogen as 2.22 and oxygen as 71.19. The atomic weights are carbon 12, hydrogen 1 and oxygen 16. So let's divide. We get 2.22, 2.22 and 4.44. Here the smallest number is 2.22. So dividing every bit, so we get 1:1:2, and hence the simplest whole number ratio is 1:1:2. So the empirical formula will be CHO2. This is the empirical formula. And now we find the empirical weight. Empirical weight is 12 plus 1 plus 2 into 16, that will come down to 45. The vapor density is given as 45 in the question, and we know that molecular weight equals to twice the vapor density, and here the empirical formula is also 45. So the common factor is 2, that is simplest whole number ratio is 2, and hence we multiply the empirical formula by 2 and we get the actual molecular formula equals to CHO2 into 2, that is C2H2O4 is your final answer. I hope guys that you have understood this question. Now let's see one more numerical. A compound of carbon, hydrogen and oxygen is found to contain 40% of carbon, 6.7% of hydrogen and 53.3% of oxygen. Calculate its empirical formula, and if its vapor pressure is 30, calculate the molecular formula. So the question is very easy. Carbon is 40%, hydrogen is 6.7% and oxygen is 53.3%. The atomic weights are 12, 1 and 16. The relative numbers of atoms will be 3.33, 6.7 and again 3.33. Dividing by the smallest number, so we get 1:2:1. So the empirical formula will be CH2O, and the empirical weight comes out to C, that is 12 plus 2 plus 16. Here we get 30 as the empirical weight. We know that molecular weight equals to twice the vapor density, and the vapor density is equals to 30, that is empirical weight. So 2 is the integral multiple for the molecular weight, that is the whole number ratio. Molecular formula will be empirical formula multiplied by 2, that is CH2O into 2, hence we get C2H4O2, and this is your final molecular formula of the given compound. Now let's look at the next question. A compound has the following percentage composition. We have sodium as 18.60%, sulfur as 25.80%, hydrogen as 4.03%, and we have oxygen as 51.58%. Now calculate the molecular formula of the crystalline salt, assuming that all the hydrogen in the compound is in combination with the oxygen of water of crystallization, and molecular weight of the compound is 248. We have something in addition to this, that is the water of crystallization. First of all, let's look at this as the regular empirical formula question. So sodium is 23, sulfur is 32, hydrogen is 1 and oxygen is 16. So the relative atoms we get as 0.80. For sulfur we get 0.80. For hydrogen we get 4.3. And for oxygen we get 3.22. And now dividing the entire thing by the smallest number, that is 0.8, we get 1:1:5:4. So the empirical formula becomes NaSH5O4, and the empirical weight will be 23 plus 32 plus 5 plus 4 into 16, which comes out to 124. And here the molecular weight of the compound is 248. So molecular weight equals to N times the empirical weight. So here N comes out to be 2, and hence the molecular formula becomes NaSH5O4 into 2, and hence we get molecular formula as Na2S2 H10 and O8. But something additional has been given in this question, that all the hydrogens in the compound is in the combination with oxygen as water of crystallization. So we have 10 hydrogen, so we can say we can get 5 molecules of H2O. So we are left with Na2S2 and O5 are consumed, so we are left with 3 oxygen, and this will be your final answer to this question. Now let's look at chemical equation. It is the balanced chemical transition reaction. In a chemical reaction, a rearrangement of particles result in change in the properties of the substance so formed. A chemical reaction gives the information regarding the molecular proportion, the relative masses, the relative volumes of gaseous of the reactants and the products taking part in the chemical reaction. And we already have studied this, and we should know this, and we have already used the same concepts in Gay-Lussac's law, mole concept and Avogadro's law. So let's see. This is one of the questions which talks about chemical equation. Calculate the weight and volume of oxygen at s.t.p, which will be evolved on electrolysis of 18 grams of H2O. Now H2O is undergoing electrolysis to give H2 and O2, and to balance this we'll get twice H2O will decompose to twice H2 plus O2. Here the weight of oxygen and volume of oxygen is asked at s.t.p when 18 grams of water has been electrolyzed. So from this equation simply we can state 2 moles 2:2:1 as per the Gay-Lussac's law. 1 mole of H2O contains 18 grams, but here we are assuming that is 2 moles and 1 mole. So dividing the entire thing by 2, we get 1 mole is to 1 mole is to half mole. And we have been asked about oxygen. So half mole of oxygen weighs 8 grams and it will contain 11.2 liters. And we have already seen this in the last couple of sessions. So that's your final answer. Let's look at the next question. Calculate the weight of potassium nitrate formed by thermal decomposition of 15.15 grams of potassium nitrate, that is KNO3. Now KNO3 is thermally decomposed to form KNO2 plus O2. Now when we take twice KNO3, we have to take twice KNO2, which will give you O2. Now as per the Gay-Lussac's law, we get 2:2:1 as the whole number ratio, assuming that all are the gases. We have to find the weight of KNO2 produced if 15.15 grams is decomposed. 1 mole of KNO3 will weigh 39 plus 14 plus 3 into 16, which will be 101 grams. If 101 grams equals to 1 mole, then 15.15 grams will be how many moles? So we get x equals to 15.15 divided by 101, that is 0.15 is your answer. So this is the number of moles, and as the ratio is constant, KNO2 that will be produced will be 0.1 mole. 1 mole KNO2 is equals to 85 grams, and 1.515 moles will give you 12.75 grams, and this will be your final answer to the question. Guys, that's a tricky question. Please go through it once again and look at it that you have understood the concept. Now let's look at the next question. Combustion of butane takes place as follows, that is twice C4H10 plus 13O2 will give you 8CO2 plus 10H2O. Calculate the number of moles of oxygen needed to completely combust 58 grams of butane. Now first of all, let's see. Now as per the Gay-Lussac's law, we get 2:13:8:10. Now C4H10 has molar mass equals 4 into 12 plus 10 into 1, that comes out to 48 plus 10, that is 58 grams, which is equals to 1 mole. Now as per this equation, when we have to burn 1 mole of butane, we will have to divide oxygen as well by 2. So 13 by 2, that is moles of oxygen that will needed be is 6.5 moles. That is your answer to the first bit. And the volume of carbon dioxide formed at s.t.p at the same time. So the volume of oxygen that will be formed is, first of all, let's find moles of carbon dioxide formed. This will be again divided by 2, that is 4 moles. And we know that 1 mole contains 6.022 into 10 raised to 23 molecules. So there are 4 moles. So 4 into 6.022 into 10 raised to 23 molecules of carbon dioxide will be produced. And that is the final answer for the second bit. Now let's look at the last question of today's session. 2.12 grams of an impure mixture containing anhydrous sodium sulphate is dissolved in water. An excess of barium chloride solution is added when 1.75 grams of barium sulphate is obtained as a dry precipitate. Calculate the percentage purity of the impure sample. Now that's a tricky looking question, but actually it's a simple question. Let's look at it how. So we are given that 1.74 barium sulphate is obtained. Now as per the balanced chemical equation, it is a balanced chemical equation. So we have 1:1:1:2 as per the Gay-Lussac's law. Now BaSO4 has the molar mass equals to 137 plus 32 plus 4 into 16, that comes out to 233 grams. That is the molar mass. Now 1 mole equals to 233 grams. 1.74 grams will be how many moles? So we get X equals to 1.74 divided by 233, which will come out to 0.0074 moles. Once we have got the moles, we know from this equation that is 0.0074 moles of Na2SO4 will be present in the pure form. So 1 mole of Na2SO4 is equals to twice into 23 plus 32 plus 16 into 4, which comes out to 142 grams, and 0.0074 moles 1.05 grams. Now the question is, calculate the percent purity in the impure sample. So percent purity equals to the amount of pure sample divided by the total weight of the sample into 100. So we get percent purity as 49.5%, and that's your final answer. It is again one of the complicated questions that we have seen today, and that's the final question that we are gonna see today. So thank you guys for watching this video, and in case you have any doubts in the entire series, please feel free to comment in the comment section below. In case you have found and you have come across some questions that you are unable to deal with, please feel free to ask in the comment section, and I will for sure get back to you on that question. Thank you. Please like, share and subscribe my channel, and please press the bell icon if you don't want to miss any updates from this channel. And I hope to see you in more such sessions based on different chapters. Thank you.